Hello and good morning, and you're welcome to today's Signpost webinar. We hope you're keeping safe and well wherever you are staying in the country. It's a little bit wet out there today. We know that nitrogen is essential for grass growth and productivity, and yet if it's used inefficiently, can lead to economic losses and environmental challenges. And today we're going to be talking about how we can improve nitrogen imbalances and use efficiency on Irish grassland farms. And we're delighted to be joined by Dr. William Burchill, who is with University College Cork, formerly of the Teagasc parish. And we have Cathal Somers, who's also going to help us with questions later on. Good morning, William. How are you today?
Good, Mark, and good, Cathal. Thanks very much for having me this morning. I'm looking forward to our discussion and to, I suppose, presenting on this topic.
Great, great. So, William, as I mentioned, you're formerly from Teagasc. Could you give us a little bit of background to your own work and career to date?
Yeah, so Mark, look, I'm originally from a farming background in West Cork, and I studied agricultural science between Clonakilty Agricultural College, MTU, and then finished off with a final 4-year degree in SETU. And from there, then my passion grew really for looking at nitrogen and nitrogen cycling, and I worked in Teagasc Moore Park, completing a PhD with James Humphreys in Salahead, which where I learned all things nitrogen. We focused in very strongly on nitrogen balances at Salahead, tried to figure out how the nitrogen enters these systems and how it leaves. So then I went on from there and I spent time in Johnstone Castle doing some research. And then I took a different slant and I changed track for a bit. I went back into advisory in Teagasc Turk, and I worked with Teagasc on the Teagasc Dairy Gold Joint Programme as well, facilitating discussion groups. So from that then, I never really stayed put for long, to be honest, Mark. So after that then, I moved back here into University College Cork, where I'm situated in the School of Biological Earth and Environmental Sciences. So we've a new and emerging ag science program here. We have a good agricultural science degree, and we're building a program of research in I suppose, applied agri-environmental sustainability. So that brings me up to the present day. I've been there for the last 2 years, and I head up lecturing in terms of soil science in the university, and I also contribute very much to this topic in the whole area of agri-environmental sustainability.
Brilliant. Thanks, William. And so you have an in-depth knowledge of nitrogen, a very topical subject at the moment. I know the Environment Commissioner from the European Commission is over today in Ireland, actually, for discussions around the new nitrates action plan, which I know is hitting the headlines at the moment. So, look, William, we're very grateful for you for coming along today. Cathal will be taking questions afterwards. Maybe just remind people how they can do that.
Yeah, it's a hugely important topic, Mark. So we have a quick Q&A tab at the bottom. So all the way during the presentation and when William's chatting there, put your questions into the Q&A tab. And when William's finished, we'll address all those questions and we'll answer as much as we can, Mark.
Great. Thanks, Cathal. And to remind everyone that today's session is recorded and will be available on the YouTube channel, the Teagasc YouTube channel, as well as the podcast version as well, which is available on all of the popular platforms. So, William, if you could share your screen with us, and we will, as I said, we'll pick up afterwards and have time for discussion. Okay, I'll leave it to you. So,
okay. So thanks again very much, Cathal. And thanks very much, Cathal and Mark, for the introduction and for the opportunity to speak today. So just to outline what I'm going to cover today. First of all, I'm going to look at what are these nitrogen balances and use efficiency? Like you said, Mark, there's a lot of topics now, or a lot of, I suppose, concern, and a lot of, I suppose, the whole area of nitrogen is very much to the fore at the moment. And, nitrogen balances and use efficiency is a new term for a lot of us out there. So first of all, I'm going to go through what they actually are and what they mean. Then I'll discuss maybe why nitrogen balances are important. Then I'll discuss maybe the current state of play in terms of where we are typically in terms of nitrogen balances in Ireland, and then discuss then maybe steps to how we can improve our nitrogen balances. I suppose the main thing we're trying to do here is to reduce our nitrogen balances and to improve our nitrogen use efficiency. So just to start off, like, and really if we're going to understand these nitrogen balances, we have to have a bit of an understanding around, you know, how does nitrogen move and cycle within our grassland farms, okay? So if we take a typical farm, okay, and I'm just outlining that this black box is the entry and exit from our farm, okay? So on any given farm in any given year, we're going to have inputs of nitrogen coming onto the farm. And these are typically from purchased stock. When we purchase meal, the meal lorry comes into the farm and brings in nitrogen with it. When we purchase silage, for example, it comes in. And if we're buying things like milk replacer as well, all of these contribute to nitrogen entering the farm. They will typically go into the livestock, you know, consumed directly by the livestock. Then we have other inputs such as fertilizer, which would be obviously a very typical one and probably the most important one, really. We have manure inputs in some cases, okay, not very typical in most places, farms though. And we also have a small bit of what we call atmospheric deposition, where there's nitrogen that's landing on the farm in the form of rainfall, or also in terms of dry atmospheric deposition of nitrogen, okay? Again, quantities of that is quite small. So they go into the system. They go into the livestock. They go onto the pastures. Our fertilizers and manure go onto the pasture. The grass grows. The animals consume that pasture, and that nitrogen moves with the pasture into the animals. Then the animals will excrete some of that nitrogen, and it goes back out into the pasture. So we're getting recycling of nitrogen in that regard. And that's also happening with the manures and an atmospheric deposition as well. Then, of a portion of those nitrogen inputs that go in, some of them then will end up going through the whole cycle. So the nitrogen will come into the animals will consume those feeds, they'll produce the milk and meat, and that milk and meat will actually ends up leaving the farm, and again, probably in the back of a lorry, okay? Also, in some cases, we'll be obviously selling livestock sales in terms of, cattle live weight, and then some cattle are going direct to the factory. Then in other cases, you know, in some cases, when the nitrogen comes in and we grow our grass, that goes into the crop, and we might sell that silage. So that, again, that's a movement of nitrogen off the farm. And like I have these in green, and this is literally what we kind of want. We want the purchased or nitrogen that moves into the farm here in blue to go through the system, and for the most of that, as much as possible of that, to end up in products that we sell off the farm: milk and meat, livestock sales, and silage being sold. Then as well, like, we can have other exports as well. You know, in some cases, farms are exporting manures as well, okay? And that contributes to nitrogen moving off the farm. And then also as well, so beyond that, then we can get things what we call nitrogen gas losses, okay? And this nitrogen gas is the nitrogen that is typically in the air we breathe. 78% of the air we breathe is nitrogen gas, okay? So some of that nitrogen that comes into the farm can get converted back to nitrogen gas, okay? And this is true when animals are in the housing. You can get nitrogen gas emissions from during that step. Also, a lot of your nitrogen emissions, nitrogen gas emissions, come from the actual pastures, okay? We also get unfortunately, environmentally damaging losses of nitrogen. So again, from our paddocks, from our fields, when we're spreading our fertilizer, when we're spreading our slurry, when slurry goes through the animal housing system and goes back out into the field, we can get losses of nitrous oxide and ammonia emissions. And we can also get nitrate, ammonium, and organic nitrogen leaching. So different species of nitrogen can get leached down through our soils, okay? So the nitrogen cycling on farms, it is relatively complex. there's a lot of movement of nitrogen. There's a lot of cycling of nitrogen, okay? When nitrogen's going through the animal, through housing, and through the manure storage, okay? And there's various losses then across the various steps and along the various pathways within those farms. And it's kind of complex, okay? So what we can do then though, okay, when we talk about nitrogen balances and use efficiency is it's very difficult to try and measure these different types of nitrogen losses, the gaseous emission losses, the losses to water at a farm level, okay, at a commercial farm level. So for nitrogen balances, we're going to remove them and we don't look and we don't try to specifically measure them because they're too difficult to measure on an individual farm basis. We don't look at nitrogen atmospheric deposition because, to be honest, the quantity is really, really small. And we start to focus in on the things that we can easily put a number on, okay? And all these values that are left here now are the things that we can easily put a number on. We actually treat the farm. We I suppose, don't really look at the nitrogen cycling within the farm. So what we look at literally is record the nitrogen inputs that go in blue and record the outputs that go out in green, okay? And this is typically where we do this. We look at it at what's called at the farm gate level. So what nitrogen comes into the farm via the farm gate. The fertilizer lorry comes in, the feed lorry comes in, the cattle lorry comes in with purchased stock, and then oppositely the milk lorry leaves the farm through the farm gate. The meat lorry, the cattle lorry goes out to bring in livestock. Maybe the slurry tanker in the odd situation will bring slurry out of the farm as well. And if we're selling silage, the silage goes out the farm gate, out on the back of a trailer, okay? So we can put numbers on these, okay? And then when we put numbers on these different inputs and outputs, we can get what's called the nitrogen balance, or some people will call that the nitrogen surplus. And that's measured in kilos of nitrogen per hectare per year, okay? So it's simply, we can put a number on the nitrogen coming in, a number on the nitrogen going out, and that will give us the nitrogen balance, okay? Or some people call it the nitrogen surplus. And in the vast majority of cases, there is generally more nitrogen going in than going out. So we end up with what's called a nitrogen surplus. Then we can look at the efficiency, how efficiently are we converting these inputs into outputs? So to do that, we look at the outputs divided by the inputs by 100 gives us our nitrogen use efficiency, okay? So that's how we can quantify that, and that's something that can be done across all different farm levels. And I suppose, why is it important? Why are we looking at nitrogen balances? Well, first of all, if we can calculate a nitrogen balance for farms, and it's quite easy, relatively easy to do that, it's a very good nitrogen balance or surplus is a good predictor of the potential for nitrogen losses from our farms, okay? So then we can also assess like how effectively we are using nitrogen on our farms, and that's what we call the nitrogen use efficiency. And these are relatively easy to complete, and they allow us to compare different farm systems, different management practices to see, how does that impact on the nitrogen surplus? And that nitrogen surplus then is a relatively good predictor of potential for nitrogen losses from our farm. Because if that nitrogen isn't ending up in milk and meat or in saleable products, it's there, and it's there has potential then to be lost to the environment, okay? So,
William, there's a small tab at the bottom of your screen there. Would you be able to click on hide there? There's a hide option. If you just click on hide there, that'll just, yeah, that's great. Thank you.
Okay, so if we determine the nitrogen surplus, then I suppose one of the questions then is like, where does this surplus end up? And I suppose the answer to that really is that, from some of the studies we've looked at already, is that it can vary widely based on our soil type. So there's a very nice review here by Murphy et al. And they looked at nitrogen leaching on well-drained soils, moderately drained soils, and heavy drained soils. And kind of what this was showing us is that as the nitrogen surplus is increasing on our well-drained soils and on our moderately drained soils, that typically we're getting a higher level of nitrate leaching. Okay, so if we can, what this is telling us is if we can reduce our nitrogen surplus on moderately and well-drained soils, we're likely going to reduce our nitrate loss to water. Okay. So we're talking about maybe around 33% of the nitrogen surplus being lost in well-drained soils, 17% in moderately drained, and heavy drained soils, only a small amount of the surplus is lost in heavy drained soils due to, I suppose, the nature of these soils, that they don't have much capacity for water to travel down through them. And there's other processes at play. So if we just ask the question then again and continue this, like, where is the nitrogen surplus going? And this is some of my own work from my own PhD, where I worked in Salahhead to try to determine where does the nitrogen surplus on a heavy soil with impeded drainage, where does that go? Okay, so we did this for 2 years. We measured the nitrogen surplus, quantified all of the nitrogen losses that are leaving the system, and we were able to account for all of the nitrogen surplus that's leaving one of the pasture-based systems in Salahhead Research Farm. So what we found again on the heavy drained soil here, or heavy soil, only a small proportion of the nitrogen was being lost to groundwater. The biggest environmentally damaging loss was as ammonia emissions of 42%. Another percentage of it was being lost as nitrous oxide, a greenhouse gas. But one of the main findings of the study was that on a poorly drained soil, a loss of the surplus nitrogen can get what we call denitrified to N2, which is an environmentally benign nitrogen gas. Okay, it's environmentally benign. It's the same nitrogen in the air that we breathe around us. It's not damaging to the environment. So you can see that these losses and surpluses can vary across different soil types. Again, just for one more example, and there's not many of these studies that have been able to try and account for all the nitrogen surplus on different soils or across different environments. There's another one here, just an older study from New Zealand. And again, they had a free draining soil, and their losses to water was accounting for about 35%, quite similar to the Irish figure, 16% from volatilization, and 7% was going up as nitrous oxide and N2 gas from the soil. Okay, so different soil types will vary, okay, in terms of where the surplus goes. But we know quite strongly that when you get large nitrogen surpluses, on free draining soils, a good proportion, about a third of them, are going to end up in terms of being lost to water. So why are the balances important then? I suppose one thing we kind of have to look at, and there's a lot, like Mark alluded to at the very start, there's a huge amount of focus now on nitrogen, and rightly so, to be honest, because at the moment we're talking about, negotiating our derogation, and it's all about trying to improve water quality. And we know from some of the EPA reports that about 70% of the nitrogen in our water courses is defined as is predicted to have come from agricultural sources. Okay. We also know that we have a target in terms of reducing ammonia emissions by 1% by 2030, and by 5% from there on. And we also have reduction targets to reduce greenhouse gas emissions by 25% by 2030 compared to 2018 levels. Okay. And if we look at these three, I suppose, targets that we have to meet, these three environmental targets we have to meet, one thing that's a common link between all three of them is that surplus nitrogen is contributing to, I suppose, the issue. Okay, so in reverse of that, if we can reduce our nitrogen balances or reduce the amount of nitrogen surplus that we are producing on farms, that would help us to tackle three of the main, I suppose, environmental issues or environmental targets that are facing us coming down the lines, and it's one metric that will give us a win in all three. Certain areas of work that we can do or certain things we can do in our farm might give us a win for just greenhouse gas emissions or just water quality, whereas if we reduce nitrogen surplus, it will help us on all three fronts. So it's an extremely important thing to go after, okay? So in terms of that's the context of it is, and so like where are we now in terms of nitrogen balances at farm level in Ireland, okay? So the most recent Teagasc National Farm Survey Sustainability Report for 2024 for last year's figures, produced some really good information in terms of where we are kind of at a national level in terms of these nitrogen balances, okay? So you can see the trend here over time from 2019 here to 2024. And ultimately, like we were in a kind of a good trend in terms where nitrogen balances were generally decreasing over time, okay? We've had a slight increase last year, but a lot of this can come down to weather conditions. If we have to poor grass growing years and we have to buy purchase feed, that adds to nitrogen coming into the farms, okay? So that's probably what's happening here. But so like at a national level, currently now, we're at a nitrogen surplus of around 165 kilos of nitrogen per hectare, okay? Nitrogen use efficiency then of that is about 25.25%. So 25% of the nitrogen that comes onto our farms, on dairy farms, on average, is going out of the farm again in milk and meat and products that where we want it to go, okay? Our future target in terms of nitrogen use efficiency will be around 35% or greater than 35%, and to reduce our nitrogen balance by down to less than 100 kilos of nitrogen, okay, on average. There's plenty of farms that are at that and below it, but this is the figure we want to try to achieve at a national level, really, to go on at least go under 130 kilos of nitrogen per hectare. Our cattle farms then generally would have less would be less intensive, okay, and in general you'll see that our cattle farms and our sheep farms will have less intensity, and as a result will have, I suppose, slightly less nitrogen balances as well, okay, and their nitrogen use efficiency will be that a slight little bit higher in the last couple of years, okay? 27.3% and 29.5% in 2024. So that's where we are in terms of the current balances on Irish farms at an average level. So then if we kind of just try to drill into this a little bit more and start to look at what are the, I'm taking an example here of some typical dairy farms. It might be a slightly bit more intensive than the average, but just to start to drill in and see, like, okay, we have nitrogen inputs, we have nitrogen outputs, but like where are these nitrogen inputs coming from? So this is just a group of farms that I worked with recently to work out where their nitrogen inputs were coming from. So you can see we have fertilizer in the blue, concentrates purchases in the red, forage purchases in grey, livestock purchases in yellow, and slurry imports is in light blue. I think in this example there was no slurry imports. So again, you can see across the group, the main thing that really stands out anyway for me on this, and this is a fairly well-known fact, is that about 78%, a high percentage of the nitrogen that comes into our farms is typically via purchased chemical fertilizer, okay? Followed then by concentrates at about 18%, okay? So they are really the two big ones in terms of inputs. Like on average in this group, the inputs were coming in at just under 250 kilos of nitrogen per hectare. And you can see though, across the group, of this group, a particular group of farms, there was quite a bit of variability in input, okay? Some were well below the average. This red line here indicates the average. Some were well below, while some are well above the average. So this is indicating to us that, there is scope for some of these farms that are well above the group average to bring down their nitrogen inputs possibly, okay? So that was their inputs. And then I suppose this is another recent enough study from about 10 years ago. And they found, again, similar results that 81% of the inputs coming onto our farm were in the form of fertilizer and 11% were in the form of concentrate feeding. Then in terms of outputs, again from the same group of farms, again, quite a bit of variability, but the main thing that really stands out here is that the milk sales accounts for up to 88% of the nitrogen leaving the farms, okay? And these would have been more specialist dairy farms that wouldn't really have had much cattle or dry stock production on these, okay? Again, and this figure is slightly higher than, I suppose, the Melanescu study from about 10 years ago, where they had about 75% of their nitrogen outputs leaving the farm in the form of milk. But again, I think some of these farms would have been more involved maybe in some beef and livestock and production as well. So where more of their outputs would have come from livestock sales, okay? So the big one here really, as you can see in this, is that milk sales are a big contributor to nitrogen outputs. So when we put the two of them together, these were the typical nitrogen surpluses across this group of specialist dairy farms, okay? And again, you can kind of see that there's a good bit of variation across the group, okay? Some surpluses are quite high, some surpluses are quite low. So like this, what this is telling us is that, you know, there is most definitely scope for us to work on these farms to bring them down to similar nitrogen surplus levels, okay? And I suppose one of the things that comes up, I suppose, in terms of this discussion is like, what is nitrogen surplus going to do? If we try to reduce nitrogen surplus, what is it going to mean for other farm metrics in terms of milk output and sales and profitability, okay? So what we did then with this group of farms, just as an exercise, okay? What we did was I pulled out 6 of the farms which had the lowest nitrogen surplus in that group, okay? Then we pulled out 6 of the farms in the group that had the highest nitrogen surplus, okay? And then we collected a lot of different information from the farms in terms of lots of different metrics to look down through them to see how does the farms with the lower nitrogen surplus compare to the farms with the higher nitrogen surplus. Okay, so we had an average surplus here of this group, of the low surplus nitrogen group, of 122, and the average of the other group was 196, okay? So we looked at other various things. We looked at net profit per hectare, okay, across the two groups, okay? We looked at the milking platform stocking rates, okay? So the milking platform stocking rates were quite similar. The whole farm stocking rates were a little bit higher on the group with the higher nitrogen surplus, slightly higher. The grass grown tons per hectare were slightly higher on the green group versus, I suppose, what we call the red group, or the higher nitrogen surplus group. And the meal feeding was low on average across all of the farms, to be honest, okay? But still, the meal was still slightly lower on the green group versus the I suppose, the higher nitrogen surplus group. Pasture utilized was higher. Chemical nitrogen fertilizer usage was lower on the green group versus the red group. Milk solids per hectare was actually quite constant, okay? You know, so the level of output they were producing was quite similar. And one thing that stood out, now all of the farms had exceptionally good soil fertility, it must be said, but the soil fertility on the green group was just a little bit better than the other group, okay? So like what I kind of can conclude from this really is that, you know, looking at this, having an appropriate stocking rate for the level of your grass grown is important in terms of having a lower nitrogen surplus. These farms that had a lower nitrogen surplus had reduced feed and fertilizer inputs. Importantly now as well, especially from an economic point of view, they had similar levels of animal performance, okay, and similar levels of milk solids output per hectare as well, okay? And they had, you know, not to overstate this, but their profitability wasn't compromised when they reduced their nitrogen surplus, okay? And another thing that was a key thing that really stood out was they had excellent soil fertility and had been able to reduce nitrogen fertilizer inputs and maintain and even have slightly better grass growth compared to the other 6 cohort farms, okay? So that's just to show in terms of like, I put this up really so just to show that like nitrogen surplus and reducing your nitrogen surplus figure is not something that people should be afraid of, okay? You know, it can be done, and I think this small case study here really highlights that, you know, the farms here on the left-hand side of the green, they were able to do this without compromising their milk output or compromising their profitability, okay? And there was a nice reduction there from, you know, 196 to 122 kilos of nitrogen surplus. So the next thing I would just say to people is, so look, we know the importance of it now, and we can see why people would do this. You know, and we can kind of see from that case study that it's not something that people should be overly afraid of. Okay. So the next thing I would kind of encourage people is to go and like find out your own figure. Okay. And where can you do this? So, you know, nitrogen, I would have worked strongly with the people in Teagasc to develop a calculator on Pasture-Based Ireland, and that's pasture-based software is freely available across Ireland, and you can go into Pasture-Based Ireland and there's a calculator in there, easy to use calculator, and it would allow you to calculate your nitrogen surplus and your nitrogen use efficiency. Also, as well, like recent developments now within the AgNav portal, which is being used to work out your carbon footprint at your BS sustainability audits. As in recent times, they have Jonathan Hearn has added a nitrogen use efficiency and nitrogen surplus calculation to AgNav, so people will be able to get access to their own nitrogen surplus figure when they complete their BRB and sustainability audits. And I would really encourage people to ensure that the fertilizer and the meal purchases figures that they give to the auditors is as accurate as possible, so that they get their best possible value for their own figure, so their own figure is very accurate within that. And also as well, just to highlight that under the Farming for Water EIP, there's actually funding available to farmers to actually go and complete their own nitrogen use efficiency and nitrogen surplus figure. So there's funding of about €250 per year for farms that are in priority action areas for water to go and actually complete their nitrogen use efficiency figure with, the team of advisors that are available on that, okay? So again, there's funding for that, €250 per year to go and do this, okay? So that's where you can know your own figure. And then just in terms of like how can we improve these figures? How can we reduce our nitrogen balance or improve our nitrogen use efficiency? So there's a couple, like, and this is a very simplified diagram. Like what we can try to do really is try to reduce our nitrogen inputs, our fertilizer, our meal, okay, while maintaining or holding our outputs. And if we do things like that, that should help us to maintain or to reduce our nitrogen surplus. Another situation is if we hold our inputs and improve our outputs, maybe improve our milk production, get more nitrogen moving off the farm. And obviously the final case thing, which can be a little bit harder to do, but it's still possible, is to reduce our inputs and increase our outputs. And that is going to give us the biggest win in terms of these figures, okay? So what are some of the typical, I suppose, just within this, the things to be really conscious of is that nitrogen fertilizer and purchased concentrates contribute to 90% of our inputs. So if we're talking about reducing inputs, it's going to be on the lines of nitrogen fertilizer and purchased concentrates. And in terms of holding outputs or improving them, it's all around the area of milk, really. Milk is accounting for about 88% of our outputs at specialized dairy farms. So what are the options? So one of the things we can do in terms of reducing nitrogen inputs while maintaining grass growth and maintaining our outputs is obviously around the whole area of nitrogen fixation from clover. Can fix between 150 to 200 kilos of nitrogen per hectare per year. And like some of the key things to take away from this, and I'm not going to go into this in detail because I know that you've had recent, webinar series from, Michael Egan and from James Humphreys that have really gone into great detail on this and great insights on how to manage clover. But just from some of my own work back during my PhD, I really found that your clover content, increasing your clover content was vital in terms of increasing the amount of nitrogen you fix every year as one key point. And the other one I would say as well is that, and we need to be aware of, is that as we increase our nitrogen fertilizer inputs, the amount of nitrogen fixation that we get reduces as well, okay? And one thing I would say is you can get annual variation in fixation. This was 2012, this was 2011 from my own study, okay? So using clover to reduce nitrogen fertilizer input is one. Another one then is around the whole area of, I suppose, improving soil fertility on our farms. So Philip Murphy and David Wall did a very nice study a few years ago where they went out onto farms and looked at the soil fertility of individual paddocks across dairy farms for 2 years. And they looked at, how did the soil fertility of the field affect the nitrogen recovery by the grass? Okay, so like how well did the fertilizer that was put on, the slurry that was put on, how well was that recovered by the grass in terms of efficiency in terms of that regard? And they found that with low soil fertility, as you improve soil fertility, got individual items of soil fertility correct, the lime, the P, the K, and when you got all three correct all together, you essentially were doubling the nitrogen recovery in your grass. Okay, so like this is something that we have to do in terms of allowing us to, I suppose, improve our nitrogen use efficiency at the farm level as well. Then as well, look, again, we can look at, I suppose, just making sure that when we are using our nitrogen fertilizer, that we use it really well, do it really correctly, and follow what we call the 4 R's, like, the right place, in terms of modern technology, we have tractors with fertilizer spreaders with GPS systems, that can do headland management and, do the short ground, that's not overlapping, okay? So that fertilizer isn't doubly applied or wasted. Applying fertilizer at the right time, looking at particularly around the springtime in terms of making sure that we get the fertilizer on, when soil temperatures are correct, when the growth conditions are correct, and also being conscious that we're not spreading fertilizer too late in the autumn either as well, when we're going into a period of the year when grass growth is declining and when mineralization of the soil is actually quite high. So we can, make allowances to, reduce our nitrogen fertilizer around those times, while like not going too late into the open period for spreading fertilizer. Then there's the things about, getting the right rates of fertilizer, like we need to look at, like what amount are we applying, making sure that we're not over applying nitrogen, be on silage ground or in individual grazing rotations, so matching the right rate of nitrogen for the right time of the year, and then the right type of fertilizer again, maybe using things like protected urea as well, making sure that we apply the protected urea will help us to reduce our potential for losses from ammonia volatilization. And if we're losing it from volatilization from our fertilizer or from our slurry as well, that's going to contribute to a higher nitrogen surplus and lower nitrogen use efficiency. So they're kind of standard things, again, like some of the old and mix of old and new research that's out there as well. Like, there's some old research looking at saying that about 30% of our soils in the country, across the country, are deficient in sulfur. And we know that sulfur is vitally important in terms of improving nitrogen use efficiency in terms of our chemical fertilizer. So like there was a very nice study conducted by Claire Aspel, where she looked at putting on nitrogen with and without sulfur. And you can see there's significant increases in grass growth that she achieved when she applied sulfur compared to applying just straight CAN, okay? So sulfur is important in terms of building blocks for protein and it's really good at improving the efficiency of our nitrogen fertilizer. Also an important finding as well is where they applied slurry and can versus applying slurry and can and sulfur, they actually got improvements in terms of grass growth as well. So just to be conscious that our slurries, while they are a source of sulfur, they generally don't have enough sulfur to supply enough to meet crop demand, okay? So in comparison then as well, at the same time as increasing grass growth, we can find that where sulfur was applied, it actually reduced nitrate leaching as well. So our can treatment, so with just nitrogen only, where we put on can with sulfur, you significantly reduced leaching losses, and the same when you had slurry can versus slurry can and sulfur, okay? So sulfur is an important one, and here are just some of the typical recommendations in terms of sulfur for grass growth. Slurry management, we should be using things like our trailing shoe, our dribble bars, we'll get more units of nitrogen from our slurry, and apply that in the springtime. So we're getting more nitrogen from our slurry. And I suppose making sure that when we do apply the slurry, that we cut back on the fertilizer we use, okay? You know, if we're going to get more nitrogen in our slurry from applying at the right time in spring and from using our low emission slurry technologies, we should be cutting back the bag fertilizer then to suit. Then as well, you know, another area as well is all around the area of having an appropriate stocking rate. So if we stock our farm according to the amount of pasture that we grow, it helps to ensure that we're not importing excessive amounts of imported feed in the form of concentrates, or even in the form of, I suppose, purchased forage. Okay, so like there's a strong link here and a good relationship developed here to show like the level of grass growth that you produce on your milking platform. Well, what's the appropriate whole farm stocking rate, which is the intersection between the green and the yellow here, and what's an appropriate milking platform stocking rate, which is the intersect between the orange and the red here. Okay, so this is just an example showing for growing 14 tons on the milking platform. Also, look, and then I suppose just to wrap up and just to summarize really, like what are the different options available to us. So like, there's loads of different ones, and I only really had time to go through some of them there. Like, but some of the key take-home ones is to reduce our nitrogen fertilizer and our clover-based swards. Make use of that fixed nitrogen from clover. Match our stocking rate to our grass growth. Try to, where we can then to reduce meal usage and the crude protein content of that meal. The higher the crude protein, the more nitrogen is in the meal. So if we can reduce both, it'll reduce our inputs of nitrogen. Increase milk from pasture, and I have in brackets here particularly homegrown, so things that we can do to improve our milk output from pasture, such as using the EBI, having a good 6-week calving rate, genetics obviously, and good grazing management. So if we have good grass quality and can reduce our levels of meal input based on good grass quality, and increase our milk production based on good grassland management, that's all going to help us in terms of our nitrogen surplus, because we'll have more nitrogen outputs going out in milk. In terms of nutrient management, we need to get soil fertility right. There's a big job of work to be done across Irish farms in that regard, getting the lime out, getting the P's and K's out, so that make sure we get best use of any nitrogen, that fertilizer that we do spread. And the lime will give us a release of nitrogen from background, our soil mineral nitrogen, soil organic nitrogen. Applying slurry in the appropriate timings and methods, and getting the distribution right, getting the slurry out to our index 1s and 2 soils, and getting it out to our silage ground. That's all going to help in terms of overall efficient use of nitrogen within those swards and growing homegrown feed as well, okay? And finally then a bit on sulfur, again, making sure that we're including sulfur in our fertilizer formulations to ensure that it gets the best out of every unit of nitrogen we're spreading. So I suppose just to conclude and to wrap up, look, nitrogen balances, they're a good predictor and a good way to reduce potential for nitrogen losses. If we can reduce nitrogen balances, we're going to reduce the potential for nitrogen losses on our farms. I'd advise everyone to make sure that you know your number and to use your own number. And once you know your own number and you have your baseline, you know where your starting point is, there's various options out there then to reduce nitrogen balances, okay? And these aren't very restrictive in terms of, I suppose, grass growth, or they are not very restrictive in terms of, I suppose, the economics of the farm as well. So not something to be afraid of. So look, with that, I'll just say thank you very much for your time and attention, and happy to take any questions.
Thanks, William. Really enjoyed your presentation there, and it's great to go back to basics sometimes with these things as well, just to understand the flows. And it really is a balancing act, isn't it? To getting that soil fertility right. And I know I can understand for farmers, the fear is that they will lose production if they do go down a little too low, or with their nitrogen, and allowing for that clover to kick in as they expand it across their farms. A question for you there, just as it's a general question, and look, it is obviously varies depending on where you are in the country, but what is an environmentally acceptable level of nitrogen surplus? Do we have a figure there, or is there, when farmers are doing that exercise through the Waters EIP, what are they aiming for?
Well, first of all, anyway, Mark, I think people need to look and benchmark off of the national average first. See where they are compared to the national average figure. Okay, I think that's your starting point. So the national average there is 165 kilos of nitrogen surplus per hectare on dairy farms. Okay, so first of all, look at that, and then I would be encouraging them to look at reducing nitrogen surplus to below 130 kilos of nitrogen per hectare. And to be honest, Mark, there's some farms that we will look at, and they have nitrogen surplus figures as low as 100 kilos of nitrogen per hectare. So it's really, you see, every farm is going to be different in terms of its constraints, its soil type. Some farms may be struggling with terms of soil fertility, and they all have to try and improve those things first, and then I suppose try stepwise work towards incrementally reducing that nitrogen surplus. And I suppose one thing I would have to say to people, and they have to be conscious, is that the nitrogen surplus will go up and down in different years depending on weather. If we have a difficult grass growing year and there's more meal purchase and milk production goes down, that's something that we just may have to live with, like, do you know what I mean? So I would be thinking that people need to look at this kind of slightly over the longer term period as well, that if they can be making incremental reductions over time, and there will be the years where it'll be slightly up, and there'll be years where it's slightly down. But if the overall trend over time can be declining, I would think that that's what people need to do, as opposed to, I wouldn't pin them to a single figure. Okay, if every farm can be making incremental reductions over time, and this figure, it's going to make a big difference to us.
Well, I think that facility there for farmers within the priority areas is definitely something that we probably will see expanded across the country. Cathal, I know that you're involved in that to some degree, but at the moment it's just available to those farmers that are located within the priority action areas. Is that correct?
Yeah, and large parts of particularly the southeast, if you're dairy farm and the end surplus, there's actually a payment where you can get your end surplus done. So you fall into that category if you're doing dairy farming in, some of those areas are expanded because you're in that more, I suppose, free draining soil. So it's a really good option there. If you get approached by an advisor, take your hand off it, because, like as William said, this is a real bedrock of where your farmer is operating, and you can implement actions after that.
Great. Lots of questions coming through there, Cathal.
Yeah, William, you're popular. Look, there are lots of people saying well done on the presentation, but first and foremost, is there a correlation between N inputs and N balance?
Yeah, like typically, Cathal, what you will normally see is that as your inputs are increasing, your in surplus generally will be increasing as well. Okay, like I went through the different options there in terms of trying to reduce your nitrogen surplus, and if we looked at those case study farms, their nitrogen outputs were relatively similar, but where they were making the real win in terms of nitrogen balance is where they were holding their outputs, their milk production, holding the milk production, but actually doing that and actually reducing their level of nitrogen inputs then. That's where those farms were really making a difference in terms of, I suppose, reducing their nitrogen surplus. If we remember those two examples of the case study farms, they had similar levels of milk solid. They were both maintaining that. But normally what you can see at farm level is that there's generally a larger variability in terms of the nitrogen inputs. So I would be really thinking if people can hold their outputs and hold their milk production while reducing their nitrogen inputs incrementally. And I suppose we have to be careful on that as well. Like, this doesn't mean that we go out in the morning now and stop and completely reduce our nitrogen fertilizer, because if we do that, and we don't have ways of mitigating that, or to growing the grass in other ways in terms of clover or improving soil fertility, what we'll end up actually doing is just purchasing in more feed, and that's just nitrogen coming into the farm in a different form. And also it's in a form that is obviously much more expensive.
Yeah, and there's a couple of comments around that actually that we can see that, and you mentioned yourself, in extreme years, be it drought or be it wet years, that we end up doing a lot of buffer feeding, and some of your graphs are showing that extra inputs, a concentration or buffer feeding actually can contribute a lot of input of nitrogen to the system.
It can, Carl, but then I suppose like maybe what people need to look at is over time you need to try to set your stocking rate to the level of grass you're growing. Do you know what I mean? And there will be years around that where, you know, you're going to have years it might be slightly lower grass because of drought on free draining soils. Then there'll be years on heavy soils where you'll have wet weather and stock won't be able to go out. And then typically in those situations, more meal has to be fed to, you know, to maintain, or more meal is fed when animals are inside on silage. You know what I mean? And I think we need to be conscious of that, and we need to think of this in terms of on a practical point of view, that, you know, people will have to look at this over the longer term period, and there will be bumps in the roads. There will be years where their surplus will bounce up because of that. But if they can, you know, over a longer term period, have a general trend in declining the nitrogen surplus, I think that's all that we can kind of, I suppose, ask people to do. To be honest.
Yeah. A lot of comments around and interest around your tables, where you show the difference between the farmers with the lower end surplus and the higher end surplus. The lower end surplus did very well and had lower overall stocking rate, grew more grass. It done really well compared to the one with the higher end balance. Can you maybe comment on that?
Yeah, well, like I suppose in that, what I would think there, like, is that those farms they were stocked more appropriately for the level of grass that they were growing really. Like, there's a few different things on that. Like, so, like with the nitrogen balance, like, you know, you have to think about it. What you're essentially doing is you're effectively using your nitrogen inputs, you know, and if you just change the unit from nitrogen to euros, it's the same thing. Like, you know, like if you were effectively using your inputs at farm level and getting similar levels of output to the farms that are spending more on inputs, like, you know, your profitability will be better. Like, do you know what I mean? So, I think on that, like, obviously, what was being shown there was that the farms that had a lower nitrogen surplus, they had absolutely fantastic soil fertility. So any nitrogen fertilizer that they were spreading, they were getting the best effect of it. Okay. Now, one thing we didn't look at, okay, and we probably should have looked at this, is more than likely some of those farms in the green side had clover, okay, and that was probably allowing them to reduce their nitrogen fertilizer usage as well. But their soil fertility was excellent as well, which we all know probably from last week's webinar, that soil fertility is vital for clover, okay. Also as well, like, so you could see as well within that they had slightly less concentrate usage as well. So like they were very muchly matching their stocking rate to the level of grass that were grown. And like even outside of nitrogen surplus, that's a really strong, you know, environment or economic metric that we would be advising people to follow. You know, is that you should be stocking your farm to, I suppose, what the farm can actually grow to
William,
make sure that you're not spending
yeah,
inputs. Yeah.
sorry, come across you there. Just on you mentioned clover there a minute ago. There's a load of comments on clover. Um, is it possible to look at including clover into the balance, or how tricky is that? You know, clover seems to be fairly key. Like you can see some of those farmers, they're way down on nitrogen inputs, chemical. I think it was a 153 or something like that, the average. But they're obviously doing clover really well. But can you capture that in the balance?
Yeah, you see, and this is something that comes up a lot, you know, and like technically speaking, you should be quantifying the nitrogen coming in to the farm via clover, but it's really difficult to do that. So these balances, what we call them a farm gate nitrogen balance, okay? And I suppose the idea behind that is you look at everything that goes in and out through the farm gate, okay? So normally in like if we were doing research, okay, normally what in research you would try to quantify the nitrogen that's being fixed in the clover, and you would add that in as an input, and that generally then will bring down your efficiency and actually increase your in surplus. But one thing I would argue is that if we're trying to reduce these in surpluses, there's three things we're trying to do. We're trying to reduce the impact on water quality, we're trying to reduce the impact on ammonia, and trying to reduce the impact on nitrogen fertilizer. So from a water quality point of view, a kilo of nitrogen fixed versus a kilo of nitrogen fertilizer coming into the farm, it from the work that's out there, and there's limited enough work on it, the impact might be relatively similar in terms of water quality. Some studies would suggest it's the same. Some studies are suggesting that it's slightly lower impact because the nitrogen from clover is a more of a slower release type of nitrogen, okay? Then if we look at it from an ammonia point of view and a nitrous oxide point of view, every ton of chemical nitrogen that comes into the country, you are multiplying that by an emission factor, and that's contributing towards our nitrous oxide and our ammonia emissions from our farm, from agriculture, okay? Whereas with every kilo of nitrogen that's fixed from clover, there's no ammonia or nitrous oxide emissions associated with the introduction of that nitrogen into the system. So I would argue that, okay, some of these surpluses may look very good and efficiency may look very good with clover, okay? But I would argue that that nitrogen that's coming in is actually way less environmentally damaging in terms of ammonia and nitrous oxide for definite. And I suppose there's a little bit more work to be done in terms of water, but it's no worse than I would say than chemical fertilizer. I hope that answers the question.
Thank you, William. Unfortunately, we've just run out of time. Lots and lots of questions. Huge interest in this topic. I guess it is a very topical subject at the moment, and a lot of comments there, observations there around the profitability and the lower nitrogen surplus farms there as well. So it's great to see that information presented. William, thanks so much for joining us this morning. No doubt we'll be hearing about this again sometime soon, given the focus on this topic. Cathal, thank you so much for helping with the questions this morning. We have just circulated a link to the conference proceedings from last week's Water Quality Conference, which I think will be of interest to everybody who's involved in agriculture. Next week, we have a very different sort of webinar for you next week. We're going to be joined by Cathal Somers, who is a tillage farmer and the recent winner of the Teagasc FPD Environmental Sustainability Awards. And we'll also be joined by John's advisor, John Pettit, and Siobhan Kavanagh. So it's going to be a very interesting webinar, hearing directly from Cathal Somers as what's happening and what he's done on his farm to be recognised as Environmental Sustainability Award winner. So until next week, do take care, and we hope you enjoyed the weekend. So thanks again for joining us.